For creating an IPC compliant footprint and its naming convention, we have to follow few standards. In this video, I'll cover application of IPC-2222-A and IPC-7251 standards while creating a LAN pattern for TQFP-32 package. So let's get started. This is section 1 and here we will create pad stack for TQFP-32 and save it using IPC naming convention. As you can see on the screen, I have package detail and its dimensions from the datasheet of ATmega328P. For creating a pad stack, open Cadence Pad Stack Editor 17.4. To create a pad stack for SMD component, we have to follow only 4 steps. First step is we have to select the pad stack type and its geometry. So in our case, it will be SMD pin and rectangle. In the next step, we have to click over Design Layers tab. And here from the regular pad column, we have to firstly select that and fill the dimensions of pad. So from the datasheet, we'll get the information of width and height. In this case, we're going to fill all the details in mils. So make sure you are using correct unit here. As per datasheet, its width is given 0.37 mm. And if we'll convert it into mils, it will be 13.78. So let's fill that information. In the next step, we have to put height detail, which will be length of the pin. So as per datasheet, it is given 1 mm. If we'll convert it into mils, it will be 39.37. And as per IPC standard 2222-A, we have to put some extra length on pad stack. That is 25 mm. So we have to use the formula. The total length as per IPC standard will be is equal to length of the package plus 25 mm. So in our case, it will be 64.37. Now we can move to another step. Next step is mask layers. In the mask layers, we have to fill the details for solder mask top and bottom and paste mask top and bottom. If we'll select the solder mask top, here we have to fill the width and height of pad. And as per IPC standard 2222-A, this width and height will be slightly higher than the pad's dimension. And here we're going to use a formula. Width of a solder mask top will be pad width plus 6 mm. And similarly for height, it will be height of pad plus 6 mm. So let's add these dimensions as well. And we have to put the same details for solder mask bottom. For that, we'll just copy it and paste it. Now let's put the dimensions for paste mask top and paste mask bottom. For this, as per IPC standard 2222-A, it should be same as the pad's dimension. So let's put the pad dimensions here. And we'll copy it and paste for bottom as well. So till now, we have filled all the details in mask layers. Now the next step is we have to save the pad stack. To save it, we have to click over this Save Now button. And we have to locate where you wanted to save it. In my case, I'm going to save it on desktop. And here for naming convention, we're going to use IPC standard 7251. So this is a rectangular pad. So it will start with R. Then we have to enter the length of the pad in mm. So which will be 164 underscore width of the pad, which will be 0.37. So it will be 037 and let's click over Save button. As of now, we have created the pad stack for TQFP-32. Let's close Pad Stack Editor and open PCB Editor 17.4. This is section 2 and here we're going to create a footprint of ATmega328P using its datasheet and IPC standards. We'll start with creating a new package. For that, go to the File, New. Here you have to select package symbol and from here you have to browse where you wanted to save it. And here you have to enter the naming convention of the package. So as per IPC standard 7251, for TQFP it will be TQFP underscore pitch of the package, which will be 0.8, then width of the pin, which will be 0.5, Then you have to enter length of the package, which will be 7 mm, then thickness again 7 mm. Then you have to enter height of the package, which will be 1.2 in our case. And at last we have to enter number of pins. So quantity will be 32. And click open. OK. Now it is asking to put the design parameters. As of now, we'll go with the default ones. Click OK. Now in the next step, we have to edit few design parameters. For that, go to the setup, design parameters, and here you have to select the design tab. As you can see, as of now, the corner of this whole page is 0, 0, which is our origin. I just want to move this center a little bit at the middle of this page so I can place pins at the center. So let's make it -500 for X and Y both direction. And now click over apply and OK. So as you can see, now the origin is little bit shifted and we can able to see that. Now in the next step, we'll start placing pins. For that, click over this placing pin button and you have to select the pad stack first. The pad stack we created, it was a rectangular pad stack, so it started with R. So let's search for R asterisk, hit enter. And the first one is R164_035, the pad stack that we have created. Click on OK button and you can simply place it. So we'll place first pad stack at the center or 0, 0. And as you can see, for placing the second pad, it is going to 100 mil. So as you can see, the grid size is set 100 mil as of now. But in our case, pitch is 0.8 mm or 31.5 mils. So we have to enter this information in grid. Let's change the grid first. So right click, quick utilities and select grids. And here you have to enter pitch details for non-H and all H. Now hit apply and OK. I'm going to enable the grid so I can see that. Now the grid is changed to the pitch size of the component. Now again start placing pins. Select pad stack from the drop down menu. Alright, and you can simply place it like this. Then you can rotate and again go for the other manual placement. So this is one method to do it. Let's see another method. So first I'm just going to cancel this and again go to the place pin. Select your pad stack. And here you can see couple of details that we can fill. So in our case, we have to place 8 pins in each side of the component. So that means for first 8 pins, in the X direction it will be 8 and Y will be 1. And the spacing between pins will be the pitch of the component, which is 31.5. And here you have to select the order. Either you wanted to place these 8 pins in the right side or left side. In our case, we are just going to place it on the right side. So let's select right. And here also I'm just going to put the pitch detail. Alright. Now here you have to enter the rotation of pins. So as of now, it will be 0 degree. Now what you have to do, you have to just select the position where you wanted to place first pin. And if I'll select 0, 0 origin, it will automatically place 8 pins here. Now we have to right click and click over done. Now placing pins from 9 to 16 is little bit tricky. First step is we have to change the origin from this pin to this pin. For that, we have to go to the setup, change drawing origin. You have to zoom in little bit, right click, snap to pin. And as you can see, origin is shifted to 8th pin now. Now we have to do some basic math on the data sheet. So let's open the data sheet and here they have given a recommended land pattern. So we have to find out what are the coordinates of this pad from this pad, right? So the center of this pad is 0, 0 and we don't know what is the center of this pad. And here we have to use a formula which will be C1 minus 7 times pitch divided by 2. So we'll get this dimension in X direction. For Y direction, we have to apply same formula on C2, which will be C2 minus 7 times pitch divided by 2. So we'll get the coordinate of 9th pin from 8th pin if 8th pin is the center. Alright. So let's fill that details there. We'll again click over place pin, and here you have to fill all the details. So this time in the X direction we are not going to place any pin, so it will be just 1, and in Y direction it will be 8. And if you'll see the order will be in upward instead of downward, so we'll just select it to up. Now we have to rotate the pins. For rotating it, we have to just place minus 90 degree, and as you can see, pin is rotated now. Now for placing it at a particular location or particular coordinate, we have to use a command for that, and that command is X space, you have to enter the coordinate, which is 1.45 comma 1.45 in mm, but we have to enter it in mils, so it will be 57 space 57 and hit enter. So as you can see, we have placed the pin from 9 to 16. Again right click and click over done. Now we have to follow the same step. We have to move the origin from this pin to pin number 16. Let's do that quickly. For that, go to the setup, change drawing origin, zoom in, right click, snap to pin. We'll go to place pin, and this time we have to enter. So again we have to place it in X direction. So X quantity will be 8, Y quantity will be 1. And this time we're going to place in left direction. So order will be left. In rotation we have to enter minus 180. And this time coordinate will be, so this is our origin 0, 0, and we have to place it somewhere here. So as you can see, in X direction or in X coordinate, it will be negative, and in Y direction or Y coordinate, it will be positive. So command we're going to use is X space minus 57 space 57 and enter. So as you can see, we have placed pins from 17 to 24. Again, we will right click and done. Now we have to go for next set of pins. Again, we have to shift the origin from pin number 16 to pin number 24. For that, we'll go to setup, change drawing origin, zoom in, snap to pin. Alright. Now the next step is click over place pin. This time X quantity will be 1, Y quantity will be 8. In Y direction, it will be going in downward order. Rotation will be minus 270. And coordinate will be X space minus 57 space minus 57 and hit enter. So as you can see, we have placed all the 32 pins, right click and done. In the next step, we're going to place Silkscreen assembly top, first pin marker and reference designator. Let's start with Silkscreen. So for placing a Silkscreen, as per IPC standard 2222 level A, it should be 8 mil to 10 mil for different components. In this case, we are going to place 8 mil, and to do that we have to select line from here, but before it we have to change the grid. So as per IPC standard, the spacing between the edge of the pad and Silkscreen boundary will be 10 mil. Okay, so we have to change the grid to 10 mil first. Right click, quick utilities, grids, apply, OK. Now placing the Silkscreen, you have to click over line, and from here you have to select Silkscreen top. If you want, you can right click and change the color. I'm just going to use it yellow. As we have discussed, line width will be 8 mils. Now we can start placing lines. So as you can see, we have placed the Silkscreen around the component or pads. Now we're going to put first pin marker here. To do that, you have to go to the shape and click over circular shape, or you can click from this button as well. So let's select the circular shape. Here you have to enter place circle, and I'm going to use 20 mil. Create. and this is created here. I'm just going to shift it because this is not our first pin. To do that, you have to just select it, right click, done. You have to select, for selecting the circle, you have to just close all other things and select shape, and now you can drag it. So I'm just going to put it somewhere here to first pin, and this will be our first pin marker. Now another step is we have to create the assembly top layer. To create it, you have to select first whatever the Silkscreen top we have created. So we'll just select it. Firstly, you have to close this filter, click over all of button and select lines. So at once you can select the complete lines, right? So let's select it, right click, copy, and we have copied it and placed over it. Done. And right click, change its layer to assembly top. Alright, so as you can see, we have selected assembly top. So assembly top boundary is created. Now we need first pin marker as well for assembly top. To do that, again you have to click over all of and select just shape. Alright, so here we have created assembly top layer. I can show you for boundary of the component and first pin marker. Now in the next step, I'm going to place package boundary and package height. But before that, let's turn off this grid. And to place the package boundary, you have to click over setup, go to the areas and select package boundary. And you have to create it around the package. That's it. So we have placed the package boundary as of now. Now in the next step, we have to place package height. To do that, you have to again go to the setup, areas and select package height. Now in this section, you have to enter minimum and maximum height of the package. To do that, first you have to select the package boundary that we have created. So let's select it. Now we can enter minimum and maximum height using datasheet. And hit enter. Alright, so we have created package height and package boundary for the component. Now in the next step, we're going to place a reference designator. To do that, you have to click over layout, go to labels and click ref des. Reference designator will be placed on assembly drawing or assembly top. So put text name, you have to just click here, and in our case we're going to use U question mark. Right click, done. Now in the next step, as you can see, the origin is wrongly placed in our design. To place it at the correct location, what you have to do? You have to just go to the setup, change drawing origin, right click, snap to shape center. Alright, so as you can see, the origin is at the center of the component now. So for SMD components as per IPC standard, the footprint center should be at the center of the component, but for through-hole component, it should be on the first pin. Now in the next step, I'm just going to hide these pin names. To do that, you have to just click over this color dialog. Here you have to select geometry, package geometry, and here you will find pin numbers. Let's hide those, apply, OK. To assign a 3D body, you have to click over 3D canvas editor. OK. And this is the one that we have created by putting height and boundary of the package. Just put 3D body of ATmega328P of TQFP package. To do that, you have to just click over 3D mapper. Just select the model file that you have downloaded. Open. And as you can see, it is placed here. But pin marker is not correct. So as you can see, the first pin marker is here, but in our board it is at this position. To do that, we have to rotate it around Z-axis, as you can see here. To rotate it around Z-axis, let's put 90, enter, As you can see, the pin marker is at correct position now. To verify the component position, you can view to different cameras view. I'm just going to verify it from top first. So as you can see, the 3D body is little bit shifted toward upward, right? To change it, you have to just click over manual, and now you can shift it. Okay, so as you can see, now it is correctly placed. I'll just right click and click over done. Let's verify it from side view as well, and it is correctly placed. Again, click over save. Yes. Okay, so we have created our footprint using IPC standards. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.